Hello, ako si Ram at welcome sa panibagong video ng Matuklasan. Informally, sa calculus, dinidefine natin ang mga continuous function as functions with graphs that has no holes nor gaps. So kung halimbawang meron tayo halimbawa dito na f of x, graph ng f of x, at syempre meron itong domain at meron ding itong range. So, pag ginuhit natin itong graph na to without any holes nor gaps in this graph at continuous lang nating drawing without lifting our pen, then it is said to be a continuous function. Kaya naman kung meron tayong mga graph ng functions kagaya ng nandito sa left na merong hole o kaya naman ay merong gap, ang tawag natin sa mga to ay discontinuous function. For example, let us evaluate if the graph below is continuous at this particular values of x. So if x is equal to 1, ito yon, x is equal to 1, continuous ba siya at that particular value of x? Mapapansin nyo dito na meron tayong hole. So therefore, it's not continuous at 1. Pero dito kaya sa 2, ito yung 2 natin, merong hole dito and do define yung ating f of 2 dito, hindi pa rin siya continuous. So, discontinuous pa rin siya at 2. How about sa 3 kaya? Sa 3, meron tayong gap, so hindi siya continuous at 3. Kung sa 4 kaya, okay, kung mapapansin nyo dito sa 4, walang hole or gap dito sa part na to. So, ibig sabihin, the graph is continuous at 4. Sa 5 kaya, sa 5, mapapansin nyo na meron tayong vertical asymptote. Diba? So, may gap yung graph din natin dito na nakikita natin clearly. So, therefore, it's not continuous at 5. Pero sa 6, pag tinignan natin yung 6 dito, ayan, define yung point natin dyan at walang hole nor graph, no, walang vertical asymptote. So, ibig sabihin, it's continuous at 6. Okay? So, continuous yung graph natin at, alin dito, yung 4 tsaka yung 6. This time naman, kailangan nating ma-identify kung saan discontinuous yung f and why daw. So here, it's discontinuous at 1 because it has a hole here, right? It's also discontinuous at 3 because we have a gap in the graph here. So at 3, what else? Dito sa 5, may hole tayo dito. And at the same time, may gap yung graph natin dito. So ibig sabihin, kasi pati sa 5, discontinuous siya. Ngayon naman, nakita natin na madali lang ma-determine kung discontinuous ang isang function. Depende kung may hole or gap yung graph natin. Pero paano if we need to determine it algebraically? So, ito yung ruling pagka ganon. A function f is continuous at a number a if the limit of f of x as x approaches a is equal to f of a. Okay, so ibig sabihin, i-evaluate lang natin yung function at a, and then we will get the limit of the function at a or as x approaches a. Pag itong dalawang notation na to ay nag-equal, then it's continuous. And further, no, kung gusto nating ma-check kung tama ito talaga, pwede nating i-run yung mga test natin. Kagaya ng una, i-define muna natin yung f of a natin. So f of a should be defined and a should be in the domain of f. At syempre, to-check natin yung limit of f of x as x approaches a if it exists or not. Okay? So, kung na-check natin tong 1 tsaka 2, i-check natin ngayon kung equal sila. So, what if isa sa mga to ay na-violate? So, for example, okay siya sa case 1 at case 2 pero sa case 3, hindi niya na-meet yung requirement. Discontinuous yung function. So, alin man dito ang ma-violate, no? Masasabi natin ang function ay discontinuous. Let's have this example. We need to show that g of x is continuous at x equals 1. So, dito, yung f of x ay g of x na. Define as g of x. At yung a naman natin dito ay yung 1. So, kung gagawin natin yung tatlong tests, kailangan yung unang test muna ang gawin natin. Kung define ba yung g of a in this case, pero dahil ang a natin ay 1, we'll have to evaluate g of 1. At pag ginawa natin yon, this is 3 times 1 squared minus 1 plus 5. So, the answer here is 7. So, check tayo sa test 1 or sa first test na g of 1 does exist and g of 1 is 7. Ngayon, yung pangalawa naman, kailangan nating i-check kung yung limit ng g of x natin, which in this case is 3x squared minus x plus 5, as x approaches a, in this case is 1, does exist. At using the limit properties, all we need to do is to substitute a here to the values of x here. Diba? So, we'll have 3 times 1 squared minus 1 plus 5. And notice that parehas lang ang sagot, which is 7. That is why, dun sa third test, kapag tinanong natin kung equal ba yung g of 1 at saka yung limit ng g of x as x approaches 1, equal ba sila o hindi? Napatunayan natin na equal sila. So, therefore, we have shown that g of x is continuous at x equals 1 because it passed the 3 tests for continuity. This time, we need to look at these 4 functions and we need to determine kung saan sila discontinuous. Dito sa unang function natin, which is x squared plus x minus 2 all over x minus 1, kailangan nating mag-isip ng possible value na discontinuous itong function na to. At syempre, yung unang test na chine-check natin sa lahat, kung define ba siya at a particular value na napili natin. If we have f of 0 or if a here is equal to 0, then may value ba yung ating function at 0? So, f of 0, lagay mo lang dito, 0 minus 2. We have here 0 minus 1. So, we'll have positive 2. So, define siya. But it doesn't necessarily mean na continuous na agad itong function na to. Pero kung mapapansin nyo dito sa denominator, alam natin kapag meron tayong fraction kagaya niyan or rational function kagaya niyan, yung x minus 1 dapat hindi equal yan sa 0. And for this to become 0, di ba? Solve mo lang yung x na naka-equate sa 0 yung denominator. The answer is 1. So, magiging 0 yung denominator if x is equal to 1. So, therefore, pagka chinek natin siya, if a is equal to 1, define ba yung function natin? F of 1. Kung mapapansin ninyo, ayan. Okay. Hindi define yung function natin. Kasi, 1 squared is 1 plus 1, 2 minus 2 is 0. So, we have 0 over 0 or indeterminate. And because of this, we can now say that this function f of x is discontinuous at x equals 1. Pero baka yung iba sa inyo sabihin na merong definition yung limit dito kasi pwede nating i-simplify ito kapag kinukuha natin yung limit, di ba? Yes po pwede, kaso dun sa tatlong test, pag isa nag-fail, which in this case, f of 1 is not defined, then huwag na natin i-continue yung ibang test at discontinuous na siya kaagad. Try naman natin tong letter B. So, dito pa lang, pagka meron tayong split function kagaya nito, obvious na dito na nagkakaroon tayo ng clue kung saan siya possible na discontinuous. And in this case, ang pipiliin natin yung f of 0. So, sa test 1 natin, check muna natin siya at f of 0. May value ba yung function natin dito at f of 0? Yes, because if x is equal to 0, then f of 0 is 2. So, check siya sa first test natin. How about sa second test natin? We need to see if the limit of this function f of x as x approaches 0 does exist. Diba? At nag-exist nga ba yung limit ng f of x nito at x equals or as x approaches 0? Okay, kung titingnan natin mabuti, ano kaya magiging possible na itsura ng graph na to? 1 over x cube, pagka grinaph natin yung 1 over x cube, etong possible na maging itsura niyan. 'Di ba? Ayan. At alam natin dun sa mga limit properties na pinag-uusapan natin, kapag yung denominator natin dito ay nagiging 0, alam naman natin na ang limit niya as x approaches the value of 0 from the right side, ito, galing siya ng right side, di ba, is positive infinity. Then, pag kinuha natin yung limit ng f of x x approaches 0 from the left, then it's what? Negative infinity. So therefore, the limit of this does not exist kasi hindi equal yung left hand tsaka right hand limit natin. Kung gusto nyo balikan yung lesson nito, check nyo lang yung video ng about sa infinite limits. So dito, napatunayan natin sa test number 2, nag-fail siya. Bakit? Kasi the limit of f of x as x approaches 0 from right does not exist. Diba? Diba para masabi natin continuous ito, dapat nag-exist yung limit ng function nito at pasado sa test 2. So dito, nag-fail siya. So ibig sabihin, this is also discontinuous at x equals 0. O nga pala, baka napansin nyo din, paano naman yung x equals 0 at 2? Di ba define naman yung f of 0 natin? At kung ang f or ang x daw ay 0, ang point natin ay nandito sa 2. Tama naman yun. Well-define yung f of 0 natin na nasa 2. Pero kung mapapansin nyo, limit ng f of x ang pinag-uusapan natin dito. So makapapansin nyo na this does not approach the value of 2, but it approaches negative infinity here on the left side and it approaches positive infinity here at the right side. Diba? At ito yung nagsisilbing vertical asymptote. So technically, does not exist pa rin ito. Kahit na-define siya as or at f of 0 equals 2. Sa letter C, same, we still have a split function here. Sabi ko nga, ito yung nagiging clue natin kung saan siya possible na discontinuous. So here, if we'll get f of 1, the answer is 1. Kasi if x is equal to 1, f of x is 1, according to the definition of the function. So check tayo dito. We have f of 1. How about the limit of this function? Well, it is defined at f of 1. Pero it doesn't necessarily mean that this is the limit. So therefore, we need to check if the limit of this one, particularly x squared plus x minus 2, as x approaches 1 does exist. At alam naman natin kapag meron tayong case na ganito, pwede nating i-factor yan, di ba? So pag finactor natin tong x squared plus x minus 2, we'll have x minus 1 times x plus 2. Kasi negative 1 times 2 is negative 2, and negative 1 plus 2 is 1 here. So pasok. By trial and error na factoring. So cancel natin to, at makukuha na natin yung limit ng function, which is x plus 2 na lang natira, so x approaches 1. By substituting 1 here, we'll get the value of 3. Okay? So check, merong limit yung ating function. Kaso, dun sa third kaya, pasok pa rin kaya yan. Kasi, dapat yung f of 1 ay equal dapat sa limit ng f of x as x approaches 1. At kung mapapansin nyo, ang f of 1 natin ay 1. At ang limit ng f of x natin naman as x approaches 1 is 3. So, meaning it failed the third test because they are not equal. So, this function is discontinuous at x equals 1. Dito naman sa letter D is an example of a integer function. At ang itsura ng graph niyan ay ganito. At alam naman natin dito at nakikita natin clearly na ito ay discontinuous sa lahat ng integers. So 0 is an integer, so discontinuous siya dito. Even 2, 3, and so on. So obviously this is discontinuous and we don't need to check it algebraically. At alam nyo ba na kung titignan natin tong apat na function na to ay pwede natin silang i-classify into different types of discontinuity kasi napatunayan natin lahat discontinuous, di ba? Ang tawag sa letter A at letter C ay removable discontinuity. Kasi kung titignan nyo yung mga graph nito, ito yung may graph na kala mo ay defined pero merong hole, di ba? O kaya naman define siya at a certain function or as a certain value, pero hindi equal yung limit ng function at saka yung evaluation ng function at a particular value. So, that's called removable. Now, ito naman, nakita natin yung limit nito, nung limit ng f of x natin ito, nag-fail siya sa test 2, it does not exist, diba? And this is called essential discontinuity. Essential. At ito naman, yung mga special type ng function kagaya ng integer function na merong parang ladder at merong jump kagaya niyan ay tinatawag na jump or kinaklasify as jump discontinuity. Removable, essential, tsaka jump. Pero ang madalas na ginagamit lang natin na classification ay removable or essential. And formally, a function f of x is said to have an essential discontinuity at x equals c if the limit of f of x at x approaches c does not exist. Ngayon, removable naman siya at c if the limit of f of x exists and either f of c does not exist, so nag-fail siya sa test 1, o kaya naman, kung pumasa siya sa test 1 at test 2 at nag-fail siya sa test 3, it's called removable. Let's take a look at this example. Kung mapapansin nyo dito, pag dinefine natin yung function at 4, h of 4, meron tayong value. Kasi if x is greater than 4, we need to use this expression. So we have 3 here. Kasi 4 minus 4 is 0. Plus 3, that's 3. Pero pag dinefine natin or in-evaluate natin yung limit ng h of x na to, as x approaches 4, the limit does not exist. Because obviously in the graph, if it approaches 4 from left, the answer is 5. If it approaches 4 on the right side, it approaches 3. Diba? So, the limit does not exist kasi hindi equal yung left hand tsaka right hand limit natin. At syempre, kung i-classify natin itong type ng discontinuity ito, ano ito? Essential or removable? Yes, it's essential because the limit of h of x as x approaches 4 does not exist. Dito naman, pag kinuha natin yung limit ng j of x na yan, as x approaches 0, obviously, it's what? Does not exist. According to the infinite limits property, di ba? At kung i-graph natin, obvious naman, ayan. So, left-hand limit natin, approaching negative infinity. Ito namang right-hand limit, approaching positive infinity. So, di sila equal. So, therefore, does not exist ang limit ng j of x. And basically, this is again, essential. Dito naman, kung mapapansin ninyo, pag graph natin yan, merong definition yung f or g of 1 natin. Ang g of 1 natin ay 1. Pero pagka kinuha mo yung limit ng ito, 3x squared minus 4x plus 1, by applying the limit properties, i-factor nyo yung taas, may makakancel. And as x approaches 1, it approaches 2. Ayan. So, define yung limit natin, kaya hindi siya essential. Pero, discontinuous pa rin siya kasi yung g of 1 ay hindi naging equal sa limit ng g of x natin as x approaches 1. So, therefore, discontinuous ito. Pero anong type of discontinuity? It's removable. Kasi hindi naging equal. At makikita nyo naman dito sa graph, diba? Kapag naman ang given ay interval, pwede pa rin nating i-check yung continuity niya kapag lahat ng values doon sa interval ay defined doon sa function natin. So, dito maraming nakasulat, diba? Pero mas mabilis kung explain ko lang na lang to visually, di ba? So, nakikita nyo dito yung interval natin is from A to B and alam naman natin ang ibig sabihin ng bracket ay included yung value na A, di ba? So, pag yung value ng A dito ay solid dun sa function at dito sa B hindi siya kasama pero may hole naman dito sa graph, then this is continuous. But what if, itatanong ko sa inyo, on the interval from A to B, including B, continuous ba siya? Hindi. Magiging discontinuous na siya kung ito yung graph natin. Kasi may hole yung graph eh. Tapos dito sa interval, in-include mo yung B, di ba? So, hindi na siya continuous. Dito naman, yung B naman ay included, kaya solid line ito. Tapos ito ay open kasi nga may hole dito. At magiging discontinuous yan pag sinama mo yung A, kagaya ng interval na to. Dito naman, continuous siya from negative infinity to positive 0 including 0 kasi solid yung 0 natin dito. At continuous naman siya kapag 0 to positive infinity excluding 0. Tama? Dito naman, left continuous siya at x equals 0 daw. So if x is equal to 0, left continuous ang tawag natin because of this solid point. So, technically, ganyan lang naman ang ginagawa natin. Pero paano kapag ang given ay function kagaya nito? Okay, kayang-kaya yan. Kasi ang kailangan lang nating malaman, kailan ba nagiging discontinuous yung function natin? Pag nagkakaroon tayo ng hole dun sa graph, 'di ba? So, kung mapapansin nyo, hindi pwedeng equal sa 0 yung denominator. So, pag sinolve natin yan, x plus 1 equals 0, or inequate ko yung denominator sa 0, x equals negative 1. So, therefore, it is discontinuous. Discontinuous at x equals negative 1. So, ibig sabihin, i-check lang natin kung ang negative 1 ay included or excluded sa interval. So, dito sa letter A, define ba ang ating mga functions mula negative infinity hanggang negative 1? Well, here, in this case, excluding yung negative 1. Is this true? Yes, it is. It is continuous on this given interval. Bakit siya continuous? Kasi lahat naman ng possible values pwede dyan, di ba? Any real number pwede dyan. Kahit negative 5, negative 6, or decimal, pwede. Wag lang negative 1. At dito, hindi kasama negative 1, so continuous siya. How about here? From negative 2 to negative 1. Okay, continuous pa rin siya dito. Kasi nga, kung yung negative infinity kasama nga, ito pa kayang negative 2. That is within this range. So, continuous yan. But here, this interval, it's discontinuous here. Bakit siya discontinuous dito? Kasi, hindi naman dapat kasama negative 1. Dahil discontinuous na siya kapag ka nag-negative 1, ito. Kasi maging undefined yung function. So, dito, continuous ba siya o hindi? Okay, pwede naman yung mga values from negative 1 to 1 basta hindi kasama negative 1. So, it's continuous here. How about here? Okay, sinama yung negative 1. So, this continuous. Ganyan lang. Okay, paano naman kapag ganito ang function ng given natin? Well, dito, kailangan lang nating i-check kung anong ina-approach niyang value kapag nag-0 siya. Ito yung clue natin, yung 0. So, kung halimbawang nilagay ko yung 0 dito sa x plus 2, 0 plus 2, this is equal to 3. So, ang ina-approach na value nito from the left side of 0, from the left is 3. Dito naman, well, define siya as if x equals 0, it's negative 1. So, this is negative 1. And then this one, if x is greater than 0, this is 2. So, from the right, it approaches 2. So, kung mapapansin nyo, iba-iba yung values natin dito. So, definitely, discontinuous na siya sa 0. So, meron na tayong evidence na discontinuous sa 0. So, ibig sabihin, dito, possible lahat ng values maliban sa 0 kasi nga discontinuous siya doon, 'di ba? So dito negative infinity to 0 hindi naman kasama yung 0, so continuous siya dito. Dito naman sinama yung 0, so discontinuous. Dito naman, kung mapapansin niyo wala nakalagay na 0 diyan, pero alam naman natin in between this negative 1 and 1 there is 0, so discontinuous pa din 'yan. Dito naman in-exclude naman yung 0, okay, so continuous tayo dito. At dito naman, sinama ang 0. So, discontinuous tayo dyan. Kasama yan. And that's all for this video. Kung gusto nyo pa ng ibang video sa integral at differential calculus, you can click like, share, and subscribe para sa inyong mga updates. Maraming salamat sa pakikinig and see you on the next video!